The 1960s brought power and innovation to American farms, but not every tractor that rolled off the assembly line deserved to be there. Today, we're counting down the 12 most dangerous tractors from the 1960s, machines that were eventually banned, recalled, or pulled from production after causing injuries, deaths, and enough safety scandals to change agricultural equipment regulations forever. These weren't just flawed designs. They were rolling hazards that taught the industry hard lessons about what happens when engineering ambition runs ahead of operator safety. Number 12, Stiger Wildcat. In the early 1960s, a small Minnesota company called Stiger decided that conventional tractors were too small, too weak, and too limited for the modern American farm. The result was the Wildcat, an articulated four-wheel drive beast delivering over 200 horsepower, when most tractors barely cracked 100. It was revolutionary, powerful, and terrifyingly dangerous in the wrong hands. The Wildcat represented the future of large-scale farming. Stiger engineers built an articulated frame that bent in the middle, allowing the massive machine to turn in tighter spaces than a rigid frame tractor of similar length. Two massive diesel engines, some early prototypes used twin power plants, drove all four wheels through a complex transfer case and drivetrain that could pull implements no conventional tractor could budge. But that articulated joint created a catastrophic vulnerability. Under certain conditions, especially when turning on slopes or pulling heavy loads at angles, the Wildcat could jackknife violently. The front and rear sections would fold together like a closing book, crushing anything or anyone caught between them. Operators who misjudged a turn or hit a soft spot on uneven ground found themselves fighting a machine that suddenly had a mind of its own. Visibility from the operator station was another critical flaw. The Wildcat sat so high and stretched so long that operators couldn't see what was directly in front of or behind them. Blind spots extended for dozens of feet in every direction. Farm workers walking near the tractor, implements being connected, even fence posts and irrigation equipment, all could disappear into those deadly blind zones. The early Wildcat prototypes sold to pioneering farmers became cautionary tales within months. Reports filtered back to Stiger of jackknife incidents, of operators losing control on hillsides, of the articulated joint behaving unpredictably under load. The company faced a choice: pull the dangerous early models or watch their reputation crumble before it was built. Stiger chose evolution over denial. The company banned the sale of early Wildcat models until comprehensive safety redesigns could be implemented in the late 1960s. Engineers added steering limiters to prevent extreme jackknife angles, improved the hydraulic systems controlling the articulation joint, and redesigned the operator station for better visibility. The changes saved the Stiger brand and allowed the company to become a leader in four-wheel drive tractors, but those early Wildcats remain a reminder of how innovative design can become dangerous design without adequate safety engineering. Number 11, Leyland 270. British manufacturer Leyland built tractors for the challenging conditions of European agriculture. But when the company's 270 model arrived in the 1960s, it brought serious mechanical problems that turned routine farm work into potentially fatal situations. The 70 horsepower diesel seemed capable on paper, but the reality of operating a Leyland 270 revealed failures that Leyland couldn't ignore. The brake system represented the 270's most critical vulnerability. Leyland designed the brakes for normal road use and light farm work, but under the sustained demands of hillside farming or heavy implement work, the brakes would fade, fail, or simply refuse to hold. Operators pulling loaded trailers down slopes discovered their brakes were suggestions rather than commands, leading to runaway tractors that crashed through fences, collided with buildings, or rolled over when operators tried desperate maneuvers to avoid obstacles. The clutch system failed with alarming regularity. The 270's clutch couldn't handle the torque and heat generated during prolonged heavy work. Clutches would slip, grab unexpectedly, or fail completely, leaving operators unable to disengage the transmission or control the tractor's movement. A failed clutch on a slope or near obstacles meant the tractor would continue moving until it ran out of momentum, collided with something, or the operator shut down the engine, assuming they had time to react. These weren't isolated incidents. Multiple accidents across the United Kingdom involved Leyland 270 tractors with failed brakes or clutches. Farmers reported near misses, property damage, and injuries serious enough that insurance companies began refusing to cover operations using the 270. The tractor's reputation deteriorated rapidly from promising British engineering to a machine that couldn't be trusted with basic farm tasks. Leyland pulled the 270 from the UK market after the accumulation of accident reports made continued sales untenable. The company attempted redesigns and component upgrades, but the fundamental issues with brake capacity and clutch durability proved too deeply embedded in the tractor's design. The 270 became a cautionary tale about the importance of designing agricultural equipment for the actual conditions it would face, rather than idealized scenarios on test tracks. Number 10. Zetor 5511. Czechoslovakian manufacturer. Zetor built tractors that were simple, economical, and popular in European markets during the 1960s. The 5511 delivered 55 horsepower from a diesel engine that was reliable and fuel efficient, but the tractor's design included a stability flaw that made it exceptionally dangerous on any terrain that wasn't perfectly flat. The 5511's wheelbase and weight distribution created a high center of gravity that made the tractor prone to tipping on slopes. Even modest hillsides that other tractors navigated safely became rollover risks when operating a 5511. The narrow stance and relatively light rear end meant the tractor could tip sideways during turns on slopes or tip backward if the implement caught on obstacles or dug into hard ground. Zetor marketed the 5511 as an affordable utility tractor suitable for small to medium farms. But many of those farms included hilly terrain that exposed the tractor's instability. European farmers working vineyards on hillsides, managing livestock on sloping pastures, or plowing fields with varying elevation found the 5511 could transition from stable to toppling in seconds. Rollover accidents accumulated at a rate that alarmed safety officials across Europe. The 5511's lack of rollover protection meant that when the tractor did tip, operators had no structural protection. Deaths and serious injuries mounted as the tractor's stability problems became widely recognized. Farmers who survived rollovers described how quickly the 5511 would go over, giving them almost no time to react or jump clear. Zetor faced mounting pressure from safety regulators and agricultural organizations to address the 5511's stability issues. The company attempted to develop retrofit kits that would widen the stance or add ballast, but these modifications were expensive and didn't fully resolve the fundamental design flaw. The 5511 was discontinued after safety complaints made it unsellable in major markets. Zetor would later redesign their tractors with lower centers of gravity and wider stances, but the 5511 remained a stark example of how poor stability engineering could turn a functional tractor into a fatal hazard. Number 9. David Brown 990. The David Brown 990 arrived in 1965 as a capable 72 horsepower tractor designed for medium-duty farm work across British and European farms. The tractor featured modern styling and competitive power, but a critical flaw in the steering system transformed the 990 from a productive machine into a dangerous liability that ended its production run in multiple markets. The steering linkage on the 990 used components that proved inadequate for the stresses of agricultural work. The linkage connected the steering wheel to the front wheels through a series of rods, joints, and connections that needed to be both strong and durable. David Brown's design failed on both counts. Under normal operating conditions, the steering linkage components would wear rapidly, develop excessive play, and eventually fail completely. When steering linkage fails on a tractor, the operator loses the ability to control the machine's direction. The steering wheel turns freely, disconnected from the wheels, while the tractor continues moving in whatever direction momentum and terrain dictate. On roads or near buildings, equipment, or other workers, a tractor with failed steering becomes an unguided missile, weighing several tons. Multiple incidents across European markets involved David Brown 990 tractors experiencing sudden steering failures. Operators reported feeling the steering go loose during turns, during transport on roads, or while maneuvering around farmyards. The failures weren't always catastrophic. Some operators managed to shut down engines before collisions, but enough accidents occurred that the 990's steering became a recognized hazard. Agricultural safety organizations in several European countries began investigating the 990's steering system after accident reports revealed a pattern of linkage failures. The investigations confirmed that the design was fundamentally flawed and that the components were wearing out far faster than acceptable for agricultural equipment. David Brown attempted repairs and modifications, but the steering issues persisted. The 990 was withdrawn from several European markets as dealers refused to sell tractors with known steering vulnerabilities and farmers refused to operate equipment that might lose steering at any moment. David Brown's reputation suffered significant damage from the 990's failures, and the company would be more cautious about steering system design in subsequent models. The 990 demonstrated that even seemingly minor components like steering linkages could determine whether a tractor was safe or dangerous. Number 8. Fiat 640. Italian manufacturer Fiat built the 640 as an export model for international markets during the 1960s, delivering 60 horsepower from a diesel engine in a compact, efficient package. The tractor found popularity in European and British markets for its fuel economy and reasonable price, but a glaring safety oversight regarding the power takeoff shaft led to horrific injuries and eventually a ban in the United Kingdom until modifications could be implemented. The power takeoff, or PTO, is the rotating shaft at the rear of a tractor that powers implements like mowers, balers, and augers. The shaft spins at either 540 or 1,000 revolutions per minute, creating enormous rotational force. That spinning shaft can grab clothing, hair, or limbs and wrap them around the shaft in fractions of a second, causing amputations, crushing injuries, or death. Fiat delivered the 640 with an exposed PTO shaft. No guard, no shield, no protective cover separated the spinning shaft from operators who needed to work near it while connecting implements, adjusting equipment, or clearing jams. The exposed shaft was a threat every time the PTO engaged, and farm workers in the 1960s often wore loose clothing that made them especially vulnerable to entanglement. Injuries from the Fiat 640's exposed PTO accumulated with sickening regularity. Farmers lost hands and arms when sleeves caught the spinning shaft. Workers suffered crushed torsos when they leaned too close while the PTO was engaged. Some injuries were fatal when victims became entangled and couldn't escape before suffering catastrophic trauma. Each incident was preventable, caused by nothing more than Fiat's decision not to include a basic safety guard. British safety authorities moved decisively after the injury reports created undeniable evidence of the hazard. The Fiat 640 was banned in the United Kingdom until proper PTO guards were added to every machine. Fiat was required to retrofit existing tractors and ensure all new units included the protective shielding that should have been standard from the beginning. The ban forced Fiat to acknowledge that cost-cutting on safety equipment was unacceptable in markets with active safety enforcement. The company added PTO guards and resumed sales. But the damage to Fiat's reputation in the UK market lasted for years. The Fiat 640 became a textbook example of how a single safety omission could lead to injuries, bans, and lasting consequences for a manufacturer's credibility. Number 7. Case 930, Comfort King. Case promoted the 930 Comfort King as a premium tractor that prioritized operator comfort without sacrificing the 85 horsepower needed for serious farm work. The tractor delivered on the comfort promise with an improved seat, better controls, and a smoother ride than earlier Case models. But the 930 Comfort King lacked the one safety feature that would have prevented the frequent overturn fatalities that plagued the model throughout the 1960s. The 930 had no rollover protection, no cab, no frame, no structure existed to protect the operator if the tractor tipped over. This wasn't unique to Case. Most tractors in the early 1960s lacked rollover protection structures, or ROPS, but the 930's power and size made rollovers particularly deadly when they occurred. 85 horsepower gave the 930 Comfort King enough power to pull heavy implements, work steep terrain, and handle tasks that lighter tractors couldn't manage. But that power also meant the tractor could dig itself into trouble quickly. An implement catching on a rock or tree root could cause the rear end to lift suddenly, tipping the tractor backward onto the operator. Turning on slopes with the heavy implements could cause the tractor to roll sideways, crushing anyone underneath. Overturn fatalities involving the Case 930 Comfort King accumulated throughout the 1960s as the tractor's popularity meant more machines were working in more diverse and challenging conditions. Each death followed a similar pattern. The tractor tipped, the operator had no protection, and the tractor's weight crushed them before they could escape. The comfort features that gave the tractor its name did nothing to prevent these tragedies. Case eventually discontinued the 930 Comfort King and replaced it with the 70 series tractors that included options for rollover protection structures. The transition reflected growing awareness across the agricultural industry that ROPS weren't optional luxuries, but essential safety equipment that saved lives. The 930 Comfort King's legacy became a reminder of how quickly operator comfort innovations could be overshadowed by fundamental safety failures. Number 6. Oliver 1800. Oliver's 1800 represented the company's push into higher horsepower territory with a 92 horsepower diesel engine that could handle demanding farm work. The tractor ran from 1960 through 1964, delivering impressive pulling power and modern styling. But the 1800's braking system was dangerously inadequate for the tractor's weight and power, leading to runaway incidents that ended the model's production after just 4 years. The braking system on the 1800 used drum brakes that were undersized for the tractor's mass and poorly designed for dissipating the heat generated during prolonged braking. When operators needed to control the tractor on downhill grades or slow, heavy loads, the brakes would overheat, fade, and eventually fail to slow the tractor at all. A runaway tractor is terrifying and often deadly. The operator loses the ability to control speed, relying only on steering to avoid obstacles, while the tractor accelerates under gravity and momentum. Loaded trailers push from behind, adding weight and speed. Brakes that worked at the top of the hill become useless partway down. The tractor barrels toward whatever lies at the bottom: buildings, livestock, other equipment, people. Multiple incidents involving Oliver 1800 tractors with failed brakes created a pattern that Oliver couldn't ignore. Farmers reported near misses where they managed to steer runaway tractors into fields or ditches to stop them. Others weren't as fortunate, suffering collisions, injuries, and property damage when the brakes failed at critical moments. Safety complaints reached Oliver's management and engineering teams with enough frequency that continuing production became untenable. The company discontinued the 1800 after the 1964 model year, rather than attempting a complete brake system redesign that would have been expensive and admission of a fundamental engineering failure. The Oliver 1800 demonstrated that horsepower alone didn't make a tractor successful or safe. Without brakes capable of controlling that power, the tractor became a hazard that threatened everyone around it. Oliver would redesign braking systems in subsequent models, but the 1800's short production run and rapid discontinuation stood as evidence of what happens when a critical safety system can't match the machine's capabilities. Number 5. Massey Ferguson 165. The Massey Ferguson 165 became one of the most popular tractors of the 1960s, selling across Europe, North America, and global markets. The 58 horsepower diesel delivered reliable power, the tractor was reasonably priced, and Massey Ferguson's dealer network ensured parts availability and service support. But a dangerous design choice regarding the front axle led to numerous tip-over accidents and eventual bans in parts of Europe until the design could be corrected. Massey Ferguson offered the 165 with a narrow front axle option that consisted of 2 closely spaced wheels on a single pivot point. This configuration reduced the tractor's overall width, making it easier to navigate between crop rows and through narrow gates. But the narrow front axle also dramatically reduced the tractor's stability, especially during turns or when operating on uneven ground. The physics of a narrow front axle work against stability. The close spacing of the front wheels creates a narrow base of support that makes the tractor prone to tipping sideways during turns, especially if the turn is made while traveling uphill or if the implement behind the tractor shifts weight to one side. The single pivot point allows the front wheels to swivel easily, but that same design characteristic means the front end offers minimal resistance to tipping forces. Farmers operating Massey Ferguson 165 tractors with narrow front axles experienced tip-overs at an alarming rate. The accidents followed predictable patterns: turning at the end of a field with an implement attached, navigating uneven ground, or working on slopes. The tractor would lean, the narrow front axle would fail to provide stabilizing resistance, and the machine would tip over, often onto the operator. European safety regulators responded to the accumulation of tip-over accidents by banning the Massey Ferguson 165 in several markets until the company could redesign the front axle. Massey Ferguson developed a wider front axle configuration that provided better stability and made it the standard or required option in markets where the narrow axle had been banned. The 165 continued production through 1969 with the improved front axle, and the tractor's reputation recovered once the stability issues were addressed. But the narrow front axle incidents remained a black mark on an otherwise successful tractor. The Massey Ferguson 165 proved that even popular, well-built tractors could harbor design flaws dangerous enough to require regulatory intervention and forced redesigns. Number 4. Allis-Chalmers D19. Allis-Chalmers built the D19 to compete in the high horsepower segment with a 93 horsepower diesel engine that delivered impressive pulling power. The tractor ran from 1961 through 1964, representing Allis-Chalmers' engineering ambitions during a period of rapid agricultural mechanization. But the D19 suffered from transmission failures and inadequate braking that made the tractor dangerously unreliable, especially during downhill operation. The transmission in the D19 couldn't consistently handle the torque from the 93 horsepower engine, especially when pulling heavy loads or working in challenging conditions. Transmission failures manifested as sudden loss of power, inability to shift gears, or complete mechanical failure that left the tractor immobilized or, worse, stuck in gear and unable to stop through the transmission. When a transmission fails on level ground, it's an inconvenience. When it fails on a slope, it becomes an emergency. Operators suddenly found themselves unable to use the transmission to help control speed, relying entirely on the brakes to prevent runaway acceleration. Unfortunately, the D19's brakes were poorly designed for handling the tractor without transmission assistance. The braking system on the D19 was inadequate for controlling the tractor's weight during downhill operation, especially when the transmission couldn't provide engine braking support. The brakes would overheat and fade during extended downhill grades, leaving operators with minimal stopping power. Combined with transmission failures, this created situations where operators had neither effective braking nor transmission control. Multiple accidents involving Allis-Chalmers D19 tractors with failed transmissions and inadequate brakes forced the company to acknowledge the design flaws. Farmers reported dangerous incidents where they barely maintained control, and several serious accidents involved D19 tractors that couldn't be stopped or controlled properly on slopes. Allis-Chalmers withdrew the D19 from production after the 1964 model year, following the accumulation of safety complaints and accident reports. The company had invested significantly in the D19's development, but continuing to sell a tractor with known transmission and braking vulnerabilities would have destroyed customer confidence and exposed the company to legal liability. The D19 represented a cautionary tale about the importance of matching all systems, engine, transmission, brakes, to work together reliably under real-world agricultural conditions. Allis-Chalmers learned from the D19's failures and implemented more rigorous testing and component matching in subsequent tractor designs. Number 3. International Harvester 560. International Harvester's 560 should have been a success. The 6-cylinder engine delivered 66 horsepower with smooth power delivery, and the tractor ran from 1958 through 1963, remaining widely used throughout the 1960s. But a catastrophic flaw in the rear axle design led to failures that caused rollovers, accidents, and enough incidents that the 560 became infamous in farm safety history. The rear axle on the 560 used a design that proved vulnerable to stress fractures and sudden failure under normal operating loads. The axle needed to support the tractor's weight, transmit power to the wheels, and withstand the lateral forces created when pulling implements. International Harvester's design couldn't reliably handle all three demands simultaneously. When a rear axle fails on a tractor, the consequences are immediate and often catastrophic. The failure typically causes one wheel to collapse inward or detach entirely, destroying the tractor's stability and balance. On level ground, this might result in the tractor lurching to one side and stopping. On slopes or when pulling heavy loads, the sudden loss of support causes the tractor to roll over, often trapping or crushing the operator. Reports of rear axle failures on International Harvester 560 tractors accumulated at a rate that alarmed both the company and agricultural safety organizations. Farmers described hearing grinding or cracking sounds from the rear axle moments before catastrophic failure. Others reported no warning at all before the axle broke and the tractor rolled over. International Harvester faced mounting pressure to address the 560's rear axle problems. As accident reports made clear, the failures weren't isolated incidents, but a systemic design flaw. The company initiated a recall and redesign program, attempting to retrofit existing 560 tractors with stronger rear axles and improved components. The recall and redesign efforts came too late to prevent the 560 from becoming infamous in farm safety discussions. The tractor's rear axle failures were cited in safety training, in discussions about the need for better agricultural equipment regulations, and in arguments for mandatory equipment inspections. International Harvester's reputation suffered damage that took years to repair, and the 560 became shorthand for what happens when a critical structural component fails in the field. Number 2, John Deere 2010. John Deere built its reputation on reliability, quality, and engineering excellence. The 2010, produced from 1960 through 1965, violated all three principles. This four-cylinder tractor, delivering approximately 46 horsepower, should have been a solid utility machine for small to medium farms. Instead, it became what many consider John Deere's worst tractor, suffering from hydraulic failures, inadequate brakes, and dangerous loader compatibility issues that led to its quick discontinuation. The hydraulic system on the 2010 failed with disturbing regularity. Hydraulics control the implements, operate the loader, and manage critical functions that farmers depend on throughout the workday. When the 2010's hydraulics failed, implements would drop unexpectedly, loaders would lose lifting capacity, and controls would become unresponsive. These failures occurred during normal operation without warning, creating dangerous situations for operators and anyone working near the tractor. The braking system on the 2010 was inadequate for the tractor's weight and intended applications. Brakes would fade during extended use, fail to hold the tractor on slopes, and provide inconsistent stopping power that made the tractor unpredictable and dangerous. Operators couldn't trust that pressing the brake pedal would actually stop the tractor in a reasonable distance or hold it stationary on a hill. Loader compatibility represented another critical failure. John Deere marketed the 2010 as suitable for front-end loader work, but the tractor's design couldn't safely handle the stresses and weight distribution changes that loader operation created. The front axle and frame weren't strong enough, the hydraulics couldn't maintain consistent lifting capacity, and the weight balance shifted dangerously when lifting heavy loads. The front end would lift off the ground when operators attempted to raise fully loaded buckets, creating a seesaw effect that left the tractor balanced precariously on its rear wheels. This weight transfer eliminated steering control and made the tractor vulnerable to tipping backward if the load shifted or the operator made sudden movements. The frame itself would flex and crack under repeated loader cycles, developing stress fractures around the mounting points where the loader attached to the tractor's structure. Operators reported hearing creaking and groaning sounds from the frame during loader work, audible warnings that the tractor was being stressed beyond its design limits. The hydraulic pump lacked sufficient flow capacity to operate the loader smoothly and quickly, resulting in sluggish lifting speeds and jerky movements that made precise material handling nearly impossible. When operators added rear ballast to counterweight the loader, the additional weight stressed the rear axle and transmission beyond their intended capacity, creating new failure points throughout the drivetrain. The 2010's loader problems weren't just inconvenient, they actively endangered operators and made the tractor unsuitable for one of the most common tasks on small and medium farm. Multiple accidents involving John Deere 2010 tractors created a pattern of failures that the company couldn't ignore. The hydraulic problems, brake inadequacies, and loader compatibility issues combined to make the 2010 a machine that couldn't reliably perform the tasks it was sold to accomplish. Farmers who purchased 2010 tractors found themselves with equipment that was dangerous and unreliable. John Deere discontinued the 2010 quickly, removing it from production after just 5 years, rather than the typical decade or more that successful tractor models enjoyed. The company rarely acknowledged the 2010's failures publicly, but the rapid discontinuation and the tractor's reputation among farmers spoke clearly. John Deere had built a bad tractor, and the company cut its losses by ending production and moving on to better designed models. The 2010 remains an anomaly in John Deere's history, a reminder that even manufacturers with excellent reputations can produce dangerous failures when engineering, testing, and quality control don't catch fundamental design flaws before production begins. Number 1. Ford 5000. The Ford 5000 earns the top position on our list not because it was the most poorly built tractor of the 1960s, but because it represented the clearest example of how a single design characteristic, high center of gravity without rollover protection, could transform a capable machine into a deadly hazard that required retrofits, regulations, and eventual bans until safety improvements were mandated. Ford introduced the 5000 in 1965 with a 75 horsepower diesel engine that delivered excellent power for medium to large farm operations. The tractor was well built, mechanically sound, and popular among farmers who needed reliable pulling power. But Ford designed the 5000 with a high center of gravity that made the tractor prone to rollovers, and the company initially offered no rollover protection structure to protect operators when tips occurred. The high center of gravity resulted from design choices that prioritized other characteristics over stability. The engine placement, fuel tank location, and overall architecture created a tractor that sat relatively high and had significant weight positioned above the axles. This configuration worked acceptably on level ground, but on slopes or when pulling heavy implements that shifted the weight distribution, the high center of gravity made the 5000 dangerously prone to tipping. Rollover accidents involving Ford 5000 tractors accumulated at an alarming rate. The tractor's popularity meant thousands were in operation, and the high center of gravity meant even experienced operators could find themselves in rollover situations during routine farm work. The lack of rollover protection meant operators had no structural protection when the tractor went over, resulting in fatalities and serious injuries across agricultural regions. Agricultural safety organizations, government regulators, and insurance companies began focusing on the Ford 5000's rollover problem as accident data made the pattern undeniable. The tractor wasn't failing mechanically. It was fundamentally unstable in common agricultural situations, and operators were dying as a result. Ford faced pressure from multiple directions to address the 5000's safety issues. Some regions banned the tractor outright until safety frames could be added. Others required retrofits of rollover protection structures on existing machines before they could legally operate. Insurance companies raised rates or refused coverage for operations using 5000 tractors without ROPS. Ford responded by developing rollover protection structures that could be retrofitted to existing 5000 tractors and making ROPS standard or required equipment on new production. The company also worked with agricultural safety organizations to promote the importance of ROPS across all tractor models and manufacturers. The Ford 5000 story became central to the broader movement toward mandatory rollover protection on agricultural tractors. The accident data from 5000 rollovers provided compelling evidence that ROPS weren't optional safety equipment, but essential life-saving structures that should be standard on all tractors. Regulations requiring ROPS on new tractors gradually spread across countries and regions, saving thousands of lives in subsequent decades. The Ford 5000 remained in production through 1969 with improved safety equipment, and later versions of the tractor were well regarded once the rollover protection issues were addressed. But the early 5000 models without ROPS became the symbol of an entire era of dangerous agricultural equipment that prioritized power and productivity over operator safety, an era that the 5000's problems helped bring to an end. These 12 tractors represented power, innovation, and progress during the 1960s, but they also carried design flaws and safety oversights that cost lives and forced the agricultural industry to confront uncomfortable truths about equipment safety. The bans, recalls, and regulatory changes these tractors triggered transformed agricultural equipment standards and saved countless lives in the decades that followed. The lessons learned from these dangerous machines echo through modern tractor design, where rollover protection, proper braking, stable geometry, and comprehensive safety features are no longer optional but fundamental requirements that every manufacturer must meet.